We know that quarks moving close to the speed of light are responsible for building gravity, and that their motion causes three low-mass quarks to have a much larger mass, meaning that they have a much stronger reaction to gravity when moving together in quantum chromodynamic motion than alone. This increased mass effect is not the result of a change to the quarks as they move close to the speed of light. The mass effect is because the speed of light motion matches closely with the passing gravitational field pulses, and as such, they can experience a prolonged force interaction that a slow-moving charge cannot experience. Gravitational field pulses are virtually invisible to any conceivable equipment one might imagine. They are as fast as gamma rays, but instead of being tiny focused high energy photons, they are ultra thin sheets of high intensity field. Their frequency is not one of oscillation. This huge number, which is 10 to the 23rd power, that's the same as gamma rays. This huge number is the number of these sheets that pass through matter in every second. It is double that if you consider the opposite sign sheets, which also pass through matter. Obviously, we have no current means to isolate these thin sheets coming out of a large celestial body. The sheets copy the profile of the body that produces them, so they would be like a giant bubble around the Earth. While an electron can feel the sheets, their effect is only a tiny rapid vibration. So the effect upon a slow speed electron is just a sort of a little push-pull, push-pull. So it's a very tiny little vibration. Only if the electron is accelerated near light speed in the right direction will it feel the full effect and perhaps appear to have gained a special large mass. I would suggest that the colors of the quarks correspond to their relative position in the quark motion. One color would be for the leading quark, one color would be for the middle quark, and the third color would be the characteristics of the trailing quark, which are different because slightly different speeds, slightly different forces upon the three of them. The field sheet effect, gravity, on trailing quarks is always the same. This is the fastest quark. It's always the same because these quarks are all moving at the same speed. Even if we could see quarks, we would not see an effect from the sheets because the trailing quarks are completely in sync with these sheets. Moreover, they reinforce the sheets as they pass. Thus, quarks do not become literally larger as they approach the speed of light. They simply feel a resistance force to a natural barrier that cannot be broken. The resistance force is an important part of the quantum chromodynamic stability. The resistance force is in the direction of gravity. So the quark appears to become massive due to its speed. That is all.